All right, Greg. Well, we're back. Nice to see you again. Today we've got with us Mark Bell, a semi-retired fixed equipment consultant. So, Mark, nice to see you. Nice to talk with you today.
Thank you. Appreciate you having me.
Well, thanks for agreeing to do this, Mark. We're really looking forward to the discussion, and I think a lot of the listeners out there are going to get some nuggets of gold out of this conversation. So we really appreciate it.
Yeah, Mark. So earlier when we were talking a little bit and just kind of getting to know each other, I kind of gathered that you and Greg first met in the late '80s. How'd that come to happen? How'd you guys end up meeting?
I was working for DNV at the time. I had just left Monsanto and joined Detnorsky Veritas, and Shell was one of our customers, and Mark and I wound up crossing paths on looking at some NDE applications, inspection stuff, and that's how I originally got to know Mark. And it's been, as far as I'm concerned, it's been a long, really good relationship.
Were you in the inspection group, Mark, then?
Yeah, my background, I hired in with Shell Deer Park in 1973. Hired in as a Boilermaker. I was a Boilermaker for 3 years, and I was going to school at night because I didn't want to be a Boilermaker all my life. And Shell decided to put me in the inspection group, so I became an inspector in '76. I was all of 22 years old. Didn't know what an inspector did, but it was better than being a Boilermaker. So for 10 years, I was an inspector, a unit inspector, at the crew units and vacuum flasher, hydrotreater. And then when I got my degree in '87, I moved into the engineering group there in Deer Park. And that's when I met Greg. I had an interest in NDE and obviously with D&D, who was better at advanced NDE at the time than D&D. So that's kind of how Greg and I met, was once I moved into the engineering group.
Nice. So you started out as a Boilermaker. That was what, out of high school, out of school?
Yeah, it was all in 19.
For those who don't know, how would you describe, or what would you describe the job of a Boilermaker?
It was interesting then. As a Boilermaker, we did everything with heat exchangers, furnaces, boilers, tanks, anything that was not piping, so to speak, the hardware that was not piping. So I did a lot of tray work in columns, retubing boilers, retubing furnaces, that type of thing.
Okay, so good manual labor for a 19-year-old.
Oh yeah, it was really a great job for me to learn what was going on in a refinery. The hardware was.
Yeah, that was back in the day when we had the big boiler houses, right, Mark?
Absolutely.
Yeah, there was a lot to
And,
learn in those things.
So then they moved you over into inspection. Did you ask for that, or was that they had a need and they just pushed you over there?
well, it was interesting because I had a friend that I was working with. He was also a Boilermaker and going to school at night. Boy, he was a Boilermaker trainee like me, going to school at night with me. And he got an interview with the inspection group. And I told him he was crazy. He was like 25 at the time, and I was 22. And anyway, over a week time, he talked me into calling the inspection manager. And the short story is I got the job and he didn't. But yeah, I didn't know what an inspector was. I saw when I was pulling heat exchangers, I would see somebody standing there with a clipboard in their hand, jotting down notes. And I thought that was a pretty neat job.
A cushy job?
Absolutely. When you're sitting there sweating in August on heat exchangers, trying to unload heat exchangers, and he's sitting there watching you.
All right. So moved over into inspection, thinking it was going to be a cushy job, watching everybody else do the work. What did it really turn into?
It turned into a learning process. Once I got into inspection, it was interesting. When I was a Boilermaker, of course, being a young kid, I was always asking stupid questions like, Why is one stainless shiny and the other black? None of your business. Don't worry about it. We'll tell you what to use. It was like every time I asked a question, that was the answer I got, which meant they didn't know the answer, but they just said, don't worry about it. You don't need to know. The day I got into inspection, my old Boilermaker supervisor called me, my Boilermaker foreman, called me and asked me a question. It was like, one day I don't need to know anything. The next day he's trying to get information from me. And that was the difference in being an inspector, was to you get to learn.
Yeah.
And
Yeah.
I was really lucky. My inspection supervisor had been the inspector on my units before he got promoted, and they brought me in to replace him on the units. Well, he'd been an inspector there for 30 years, so he became my corrosion control document. You know, he was telling me where to look, where the problems were, this type of thing. Can't imagine what it would have done without him.
We don't have mentors much anymore, Mark, and back then we did, right?
Oh yeah, I remember every time I had a question, I'd go to an inspector, and it's like they just stopped everything they were doing, and they would teach me. They didn't answer my question; they taught me.
Yeah.
It was just a new experience to me, where people were interested in helping me learn.
Yeah.
And that, to me, that's the fun of inspection, is the learning part. I remember my supervisor when I first came in. I'd been in there about 6 months, and everything was confusing, obviously. And I said, you know, when will I ever know all this? He said, Mark, in 5 years, you'll realize what you don't know. You know, he didn't make it sound like I was going to know everything in 5 years, but at least I would recognize what I didn't know.
Yeah.
And he was right.
Yeah.
Yeah, the more I
you
learned, the
realize
more
you
I realized I didn't know.
Yeah. So would you say they were developing critical thinking skills in you?
Well, not on purpose, but
Yeah. Yeah.
yeah, and I think that was the difference in, I think, being a craftsperson and being an inspector, particularly a company unit inspector, is to go from being told what to do, being task oriented, to being a decision maker.
Mm-hmm.
And I think that's one of the most important things we can get in our young inspectors. Look for that skill, the ability to make decisions with the information that we have, and knowing when we have enough information to make a decision.
It's a good point. Instead of sitting around and trying to continue to gather more information, be able to actually just say, okay, we got what we need. We're good, and make that call.
That's correct. But again, it's knowing when you have enough information and not making the decision before you have the information.
How were you confident in the early stages to know that you had enough information?
I was 22 years old, and I thought I knew everything.
Of course.
And again, it was one of those things, when I went to other inspectors, you know, I could always get answers. And obviously my inspection supervisor and other supervisors, it was just a great learning environment. The company was very open to sending me to schools. You know, I got to learn ultrasonics and radiography and all these neat things. Of course, you know, back then we didn't have computers. Everything was done on paper. And all the corrosion rate calculations were done in our head, if we did them. Yeah, we just looked at the numbers and said, oh, it's corroding, or no, it's not corroding. And that was pretty much it. And so everything was starting to evolve. And so I guess I was one of the lucky ones to see the advent of the computerized inspection systems, to see the advent of the automated ultrasonics and those type of things, you know, the growth in the industry. Back when we used to take PAUT UTs on tank floors because we didn't have MFE, that type of thing.
And were you guys using D meters back then, or multiple echo UT instruments, or what?
We had one analog scope that nobody knew how to use. We had what was called the Sonarray, which was predecessor to the D meter. It was an analog dial indicator. You could sit there and watch the needle fluctuate, and you guessed where it was supposed to be. So yeah, I got to see the first handheld digital meter, and that was in probably about 77 when we got our first digital readout meter.
Yeah.
Was the role of the inspector back then to be doing the actual UT inspection work, or did you have?
Yes.
Okay, so we weren't quite to the point where we had contractors that we were running.
We used contractors for radiography.
Okay.
And we did a lot of radiography. Of course, one of the reasons was if I needed to take a UT reading, I had to go out and do it myself. If I had a radiograph, I could send a crew out to do it. So, and my supervisor was a big proponent of radiography. And of course, he grew up in a time when they didn't have it. So, I doubt if there were 10 days a year that I didn't have a radiography crew working in one of my units. It was just constant.
Why did he like, I mean, was it because it was new technology for him, or was there any other reason that he was a big proponent of the RT work?
Well, he knew early on that spot UT, unless you had uniform corrosion, which was unusual, you weren't going to find the worst area with spot UT. And of course, the old meters weren't good at scanning ultrasonically. So by doing radiography, he got the picture. And he could actually see what was really, what the pipe really was looking like. And so, it was interesting because he knew that some carbon steel components corroded faster than other carbon steel components in sulfidic surfaces. Now, he didn't know that it was a silicone issue, but he knew that, I remember him telling me, if I ever found corrosion in the carbon steel system, keep looking because there's going to be some components that were going to be worse than what that I'd already found. And he was right.
Isn't that crazy?
And that's
Mark,
talking.
How did you guys pick your inspection locations back in that day?
They were pretty well shotgun in that we didn't have corrosion control documents. We didn't have damage mechanism reviews. We had two corrosion engineers. They sat about a half a mile from me, and I saw them about 3 times a year when I had a question for them. But I didn't understand the damage mechanisms. I learned gradually about sulfidic corrosion and that type of thing, but it was a matter of looking where the prior inspectors had taken readings and trying to do the same.
Mm-hmm.
So we were repeating the obvious.
Yeah. So I know back in the day, a lot of times people would just inspect everything every 3 years, unless it was the AI coming in from the insurance company looking at the boilers. Is that kind of what you guys were doing before you got a little more sophisticated in how often you do your inspections?
That's exactly how we did it. The normal interval on an internal inlet pressure vessel in a crude unit then was 3 years. Piping we did before the turnarounds.
Yeah.
So, and of course with 4 different units, I always had a turnaround going on since we did them every 3 years. I always had turnarounds going on, so I always had crews out getting data.
Yeah. It seems like I recall, I don't know when the time frame was, you probably do, of the famous Shell document that inspection companies referenced for a few decades, something like called the three wise men or the 4 wise men, something like that.
And it was the 3 wise men, and it was the predecessor, in my opinion, to API 571, corrosion mechanisms. Very similar to 571, but in a hard copy. John Reynolds was one of the authors of that. Ed Creamer was a metallurgist with Shell, who was one of the authors. And, it was just a wealth of information of what just like 571 is today.
Mm-hmm. Wasn't there something in there
It was
like rules
interesting.
of thumb, so many diameters up from a pump and so many diameters back and so forth?
I don't think it was that prescriptive.
Okay.
It talked more about the mechanisms, the temperature range, of course, it has the charts for sulfidic corrosion rates and that type of thing in carbon steel. It had the Nelson curve in it. George Nelson was a Shell person, so Shell
Yep.
had the Nelson curves since the 50s. And so that was really anything you would find in 571 today would have been in that document.
Wow.
It was interesting. I didn't see that document until I had already been an inspector for 2 years.
Hmm.
How
Why
long had
not?
it
Which
been
is kind of
around?
interesting.
How long had it been around, Mark?
I would have to say for at least 5 to 6 years.
Okay.
Yeah, they had sent me we had an inspector school. It was put on by Shell by a retired, about to retire inspection supervisor from Wood River. Put it on 3 weeks. We were at a hotel near NASA. And that's when I first saw the Three Wise Men document.
Cool.
Real quick, you said this just in passing, Mark. There were 4 units at the site at that time?
No, I had 4 as an
You
inspector.
had 4. Oh, okay. Okay. I thought that
Yeah.
we only had 4 units, and I was like, oh my, that's okay. You had 4 units.
No, actually, at the time, that refinery was a fairly large refinery. It was about 340,000 barrels per day. Had a chemical plant with resins and all that type of thing. They had just built an ethylene cracker, their first. So, it was a fairly large refinery.
Yeah. Okay. I felt like there should have been more than just 4 units there in the late 70s when you're talking. So,
Now, is that the refinery, Mark, where they were supposed to film part of Urban Cowboy?
It was. It was actually in the lube storage area. In fact, when I first hired in with Shell, I was a general helper. You hire in as a general helper. So for 3 months, I was a general helper, which means you went wherever they told you. And one of my jobs was to gauge wax tanks, which just happens to be the tank, one of the tanks that was in the movie. So I guess I knew the famous tank.
you didn't sneak your way into the background or anything?
I never even knew they'd filmed it until I saw the movie.
So
That's pretty cool.
you mentioned earlier you went and got your degree. So what prompted that, wanting to go back to school?
Well, when I first got out of high school, I went to college for 1 semester on a music scholarship, but I decided I didn't want to be a band director, so that's when I hired on with Shell. But I got enough interest in school when I was going on my own that I actually enjoyed the learning process. So once I became a Boilermaker in Shell, I decided I need to get a degree and do something besides Boilermaking. So I figured I'd major in English because I like literature. So that's what I started with. And once I decided that, the engineering side of it made more sense since I worked for an oil company, that's when I changed over to that. So it was a matter of not ambition. It was a matter of wanting to learn and wanting to do something different.
Okay. And so you went back and got your English degree. My dad's an
No,
English.
never got that.
Oh, never got the English degree. Okay. So
No, I went ahead and went the mechanical side.
Okay.
And again, that's why Shell brought me into inspection, because I was going to school at night. They thought that was a positive thing, wanting to learn, etc. So it certainly changed my opportunities in a major oil company by having a degree. But I don't think it was the most important thing in my career either. In that, I think as an inspector, just the fact I wanted to learn, I wanted to listen to people. It was always looking for more opportunities to do something else, to learn something else. like I said, I wasn't ambitious. I wasn't trying to be engineering manager or anything like that. Probably 10 years before I even thought about being an inspection supervisor. It was just a matter of, to me, it was fun.
How important do you think it is, Mark, for inspectors to have a proactive passion or desire about learning?
I think it's fundamental. I think that person that doesn't, that is task oriented, in other words, needs to do things by rote. That's inspection is not the field. It would just be a very frustrating profession in my mind.
Mm-hmm.
I think that people that are good in accounting, for example, probably would not make good inspectors, just like good inspectors wouldn't make good accountants. One of the worst things I did as an inspector was keep records. I hate to say that. It was one of the reasons I was glad I finally got into inspection supervisor, is I didn't have to do records anymore.
Yeah, writing the report.
Yep.
So,
And like I said, back then everything was by hand.
So when did the 510, I know 510 was out for many years, API 510, the inspection code for pressure vessels, but how long had the certification been out, or when did it come out?
The 510 certification happened in 1989. The first test was December of 89. I know because I think 5 people took it and I was one of them. But nobody wanted to take the first test. And John Reynolds coerced me into taking the test.
Yeah,
he
he's good at that.
In the API. He was in the API, on the API committee, and he wanted the test to succeed. So he wanted me to take it and see what I thought of it. It was interesting. He told me not to study because he wanted to see how it would reflect on the average inspector. I told him what he could do with his idea of not studying, so I studied. And it turned out to be a very interesting test in that it was an essay, that first test.
Ooh.
And I shouldn't say that 5 people took, I think 5 people passed the first test. I don't know how many actually took it. But it was interesting. It took several months for them to grade the test because they couldn't agree on the answers. And a lot of the people that grandfathered got certified long before I did, even though I took the first test. It was interesting. I took the test in Austin, Texas, and rather than put your name on the test, they gave you a number put on the test. And of course, it was not electronic. And my number was TX001.
Wow.
Single digit.
Texas.
Yep.
001. That's pretty cool. So I guess the other ones prefix started with their state abbreviation.
Yes.
Yeah.
Interesting.
So that's how they knew everybody that took, the few people that took that first test. So anyway, I did pass it, fortunately, but and I think that it was interesting because before that, the only certifications we could have were the national board. Nothing else existed. There was obviously NDE, but from an inspector viewpoint, in a refinery, there was no certification before 89. And I think that one of the things that I did early in my inspection career was take the national board test. That was in 1980. So I'd been in inspection for about 3 years. And I have to admit, that was one of the things that really changed my perception of being an inspector, because I had a piece of paper saying I was an inspector. It was a different concept. It was something that inspectors assume today. A lot of them get their 510 and 570 certifications before they ever become inspectors. I was an inspector for almost 4 years before I got my first certification. So it was a different time.
Absolutely. And that's why I think, one of the things I hear from people is just because you have a certification doesn't make you a good inspector. Can you elaborate on that a little bit, Mark?
Yes. I think that passing the test is important. I think it forces you to study, it forces to learn, it forces you to see things and learn how to use the code books. That's what it does. It teaches you how to use the code book, the standards, teaches what the standards are, that type of thing. So it's an introduction. And the certification does help in that it shows that you're okay with taking tests. Because what do inspectors do? A lot of they take tests. And it shows that they have the ability to learn and the ability to communicate. So it's, I think it was a very positive thing, which is interesting that we had inspectors for 70 some odd years before we had any API certification.
Yeah, I think another early one around that time too, Mark, correct me if I'm wrong, was getting your CWI as well.
Yeah, and after the national board, I did get my CWI, the AWS certification, which really helped me learn more about electrodes and those type of things. It was much easier than the national board or the 510 exam, in my opinion, but it taught me weld symbols, et cetera, et cetera. So it was a very good learning process for the young inspector.
Cool.
And I actually took my S&T level 3 exams early on as an inspector, well, fairly early in the 80s, probably around 84, 85, that time frame. Now, I never was a good NDE specialist, but I did pass my ultrasonic level 3 and penetrant and Mach particle level 3s. But it was more to learn the details around the methodology than to say that I was an expert in NDE, because I certainly was not.
Well, that's a good point, because I mean, I think an important responsibility of an inspector is if you're considering someone coming in and doing some shear wave or doing some other kinds of stuff, you got to separate the wheat from the chaff, right? I mean, you got to make sure that they know what they're doing when they come in to do that important job. How I'm sure that training helped you a lot with that responsibility.
Oh, it was without a doubt just understanding the nomenclature. It was interesting because one of the things I did when I was still in Deer Park, I guess, I got to go to the EPRI, that was the nuclear people, ultrasonic training.
Yeah.
Where they were starting to do tip diffraction and that type of thing. So I got to go through that training. And when I first, in 91, I moved to the Wood River refinery as an inspection supervisor. And when I first got there, inspectors were bragging on an ultrasonic technician who was telling everybody he was EPRI trained and that he could do all this wonderful stuff. Well, after about 5 minutes, I realized he had no clue. And when I asked him to show me his certification for his EPRI training, he pulled out a Xerox copy of some EPRI training documents that somebody had given him. So he had learned the words, but didn't understand the technology. But there was no way the inspectors could, understand that. It was not their skill set.
Right.
So I think that's the key. And I think one of the things I learned about a good inspection department, particularly in the larger facilities, is you get a lot of different specialists. You have one inspector that was an NDE person that knows NDE really well. You have one that was a welder, so they know welding really well. So it's kind of, you have your specialists that you go and ask questions of. I think that's really a good component of the larger groups, because they have that experience spread out through the inspection group where everybody doesn't need to know everything. It's also the disadvantage of the small site that only has 2 inspectors.
Yep. I like today, people, we have time of flight diffraction, we have PAUT, and then we have, or at least back in that day, just for the sake of our listeners who may not be familiar with the acronym EPRI, That does stand for the Electric Power Research Institute. And I know a lot of our folks, when I was at DNV, went through their training, and especially when it came to flaw sizing, because back in the day, we had to use manual UT for flaw sizing, and oftentimes we'd have to grind the weld crown flush in order to do the inspection, and don't have to do that anymore. Can you talk a little bit, Mark, about your feelings about it, how we've transitioned in over history?
Yeah, I think that it was interesting. Again, I was fortunate in when I was getting into NDE is EPRI was already around and they were already developing these more advanced techniques. And as you had mentioned earlier, even as early as '87, we had some automated UT scanning techniques, which are called the P-scan.
Mm-hmm.
And so we were starting to get the more advanced techniques, but we still had most people that were doing ultrasonic flaw sizing were doing the 6 dB drop method, which was not very easy way to characterize a flaw. So I think that more often than not, we could not do repeatable sizing. We had some good technicians, I can name a couple of them back then, who were really good and would tell you when they didn't know.
Mm-hmm.
I think that was fundamental then. Now that we have phase array ultrasonics that is computerized and we can have somebody, 2,000 miles away actually helping to interpret the results of the test, I think we get a lot better examination today than we did back then, because we didn't trust it back then, and not everybody trusts it today still. And certainly, again, it's a matter of the technician, the competency, the experience level of the technician, and their willingness to say, I don't know, if they in fact can't tell.
This is just me asking because recently had some discussions around NDE with some folks. Phased array versus time of flight. I hear UT guys say that phased array is the best thing ever, and then I talk to other people and they say time of flight's the best. Where do you sit on that discussion?
Okay. I'll first say that I'm probably not the best person to ask the question, but I'll give you my opinion.
Yeah, I'm in.
If I'm doing thinner material, that is standard wall, 6-inch pipe, 0.28 wall, and I'm trying to do flaw evaluation in that thin material, I won't phase array. If I'm doing a thick hydrocracker reactor, 6-inch shell, I'm looking for cracking at the ring supports inside, and I'm looking at it from the outside, I definitely want time of flight and not phased array. That's just my opinion.
Is that because of the physics of it? What's the reasoning there?
Yeah, I think what we saw with the manual UT before the phased array is it was better on thicker materials. Okay, you can discern the back reflection from an internal flaw, that there was a space between them. Where on the thinner material, a lot of times the flaw was tied into the back wall reflection, so you couldn't distinguish between the two. That's a little oversimplification, but again, we saw that we just weren't very good on thin wall material. And by thin, I mean less than half an inch.
Okay. Yeah, kind of adding to Mark's comment, I think back in the day when we started out, Mark mentioned the P-scan, which was a Danish Welding Institute, and then there was a system called AMData, and they were using basic pitch catch shear wave transducers on an automated scanner. The nice part about that was the precise location of indications. And then time of flight diffraction came along. The issue with time of flight diffraction on thinner metals was that you had a standing wave that would go between the two transducers. And that was that could be like a 3/8 inch blind zone on the near side, which is the side that you're scanning from. That's why it was better for thicker materials. But in the beginning, I think most people felt, and I don't know if this is still the case, Mark, or not, but that you could do a quicker initial scan to look for flaws with the time of flight diffraction. and then come back with phased array and do a much better job of characterization. So for years and years, because the phased array could walk up and down the face of a crack, um, and both of them with the computers coming in and stuff gave us such great images and the ability to go back and look at the same exact crack or blister or whatever and see if it was growing or not. But that's kind of my rule of thumb, Mark. Let me know if you agree or disagree.
Fully agree.
I, so another quick question then here, because shiny objects for management is always a big win. And so phased array, because of like at least modern phased array with the digital readouts and the pretty colors that you get compared to the grayscale readouts from TOFD. Have you found a good way to communicate to a non-technical person what they're looking at in a TOF scan versus the phased array to maybe convince them that something's there and worth going back and sizing it with phased array?
No, I think it's more important to convince them that the people that are doing the interpretation are the right people.
Oh, okay.
You know, it's trying to teach a layman legal terms versus listening to the lawyer.
Trust your people.
Yeah, I mean, we have experts that do certain things, and we need to make sure we vet their experience and their qualifications. But once we do, we need to listen to them.
Are you a fan of qualification demonstration testing? You know, for the more
Am I a fan?
operator dependent methods like PAUT and TOFD and stuff like and flaw sizing and stuff?
I am a proponent of that for any NDE, not
Cool.
just for the high tech stuff like phased array. You know, I think there have been companies, and I won't get into the name, that have done just UT thickness testing and find out how many people fail that what we consider a simple exam. When we first passed the Annex G and API 653, the tank code, it was a certification, qualification certification of tank floor inspection, doing MFE and follow-up UT. And what we found was companies were renting equipment, giving it to the people and hoping they could learn how to use it. And once we started testing, it was amazing how the quality of the technician improved, the training improved. Companies knew they had to be better at it. And we also found that, you know, the follow-up UT was, as many people were failing that as they were failing the MFE part of it. It was a matter of they were scanning too fast, typically.
Yeah.
So we were learning from the actual test. But I think once a person knows they're going to be doing a physical test, it's a much different thought than just learning the words. I mean, I can pass a written test on phased array ultrasonic, but I'm not going to be the one to do the interpretation. I know that's beyond my skill set.
Yeah, so, I mean, even well, from what I'm hearing you say too, just because it's a point ultrasonic thickness reading, don't underestimate the value of accuracy and consistency in that. What did Shell do, or you guys do, to try to get more consistent quality, just simple point ultrasonic thickness readings?
And that was interesting. That was something we did in the late 80s. And, you know, data, we were starting to computerize record system in the mid to late 80s. And we were seeing that data scatter was driving us crazy. So that was the advent of computers. We were just learning it. And we knew we had to get better ultrasonic data, particularly for higher temperature applications. Because back then, you put the transducer on and the hot plate, and you watch the thickness of the plate grow on your display, okay? And we knew that not only was the velocity different in the high temperature steel than it was in low temperature steel, the acoustic velocity, we also knew that it was changing, just the transducer itself was changing because of the temperature, affecting the actual accuracy and repeatability of the reading. So we did a lot of studies, and we actually did field studies where And after a while, we got pretty good at it. And I won't go into all the details, but we were able to write procedures where technicians, once they followed the procedures, could have good repeatability. Of course, one of the things was making sure you went back to the same location every time if you were trying to do trendable thickness data. And that was our first learning, obviously. Seems pretty obvious nowadays, but it didn't back then. And so I think that once we had our procedure, we started teaching people the procedure and why it was important. And we just saw an immense improvement in our thickness data quality. And we even put our contract NDE people through that training so they would understand the importance of it.
Yeah, and it's become so important today. I mean, now as we move into statistics and try to get better at understanding our data, we see so much scatter in a lot of something as simple as a point ultrasonic thickness reading. And getting that consistency, that repeatability is very important.
And I still see today some plants haven't learned that. They still have a lot of problems with data scatter. They fight data scatter. It hurts their efficiency as well as their effectiveness. I've been in sites where they actually, well, if it's different than it was, if it's higher this time than it was last time, they just used the last measurement, one that was taken 3 years ago. Rather than improving today's data, they just default to the easy way. And so by that, they're never improving the quality of their data. And we have millions of dollars worth of data in each refinery and chemical plant. And to not utilize that and actually improve the quality of it where it's actually a usable tool, usable data, seems pretty silly, but it sometimes it's a lot easier. And people like to take the easier way. And just unfortunately, they wind up with bad data. Again, they start going back to where we were 50 years ago, and that is just hoping you find the thin area before it finds you. And what do they say? Hope is not a plan.
Yeah. Yep. Hope's not a plan. Were you guys taking 4 points around back then? Or when did that come in?
It wasn't something we always did. And when we started doing it, obviously, we would take the thinnest area.
Mm-hmm.
We'd measure 4 points and record the thinnest one. Mm-hmm. Okay, well, then you go next time, you record, take those 4 points, well, maybe a different area was thinner. So we found, well, we weren't always trending on the same spot. Okay, so obviously it was not very reproducible. So what we started doing was marking off 4 measurement points. We call it 1 CML. But one of those measurement points would become the trending location. So we'd measure all 4, but we trend on 1. And if one of the other 3 points started corroding faster than the one we were trending, we had a new trending point. So we wound up with 2 points that we were trending rather than just 1. So the CML was multiple points every time, but we might just trend one of those points.
Gotcha. Okay. Yeah, I call those examination points within the CML or the TML.
Correct.
Okay.
And then you'd have a governing point, or
Yeah.
maybe you could have a couple of them.
Exactly right. But we would treat those as discrete entities, and that we would not trend. Some people take those 4, then average to 4 for some reason. Okay. I'm a believer, and you take the lowest one, you trend that every time until another one starts corroding faster. Then you trend it as well.
Mm-hmm.
I have not heard of averaging the 4. Yeah. That's that's wild.
There's actually one IDMS tool that does averaging. Yes, I won't say the name. Yeah, not many people use the functionality, but it will do it.
Okay.
Mark, did you guys save the data though from all 4? Like when you went out and took 4 thickness readings at a CML, did you also save and use the other data then, I assume, instead of just documenting that one thinnest area or where the fastest corrosion rate was occurring, did you also save the data from the other 3 locations for later use or analysis?
It was not part of the procedure. However, I think that my recommendation was the first time always record all 4. Okay, even if you record them in a spreadsheet and not into IDMS. That way, if one does start corroding faster than the point that you're actually trending, then you have a starting point. You can at least get a long-term corrosion rate from it.
Right. Yeah. And I was also thinking from that as well, but I was also thinking about, well, heck, you paid to have somebody take all those points. Why are you keeping one and throwing the other 3 away? Because you paid for those too, right?
And that's correct. And I think nowadays with data loggers, where you're not having to write them down and then it's just as fast, right? To record it. The key is, do you want to trend off 4 points? And that's a decision each company needs to make.
Right. And with the advent, we're seeing more and more statistical analysis and talk of AI, and some of the big consulting firms saying that, hey, you got all this data, why aren't you using it? I think some people are waking up to that.
Yeah, I think one of the things we did was we had a statistician look at our procedure, and when we talked to them, we said, well, one of the problems we have with ultrasonics is repeatability. In other words, you take a measurement, you have somebody else take the same measurement, it's a little bit different, right? And what he came up with was, okay, take 3 measurements and average them at that same point, okay? And we said, are you serious? He said, yeah, what you have is random error. Take 3 measurements, you take the average of 3, you're getting rid of your random error. And statistically, he has a PhD in statistics, so we listened to him. And it really improved the quality of our data. So when we measured the 4 points of the CML, we would only take the 3 repeatable readings at the one that we were trending.
Okay. So if it was the bottom CML, you would take 3 points within that bottom, or I'm sorry, if it was the bottom examination point, you'd take three readings at that bottom point and then average those 3.
That's correct. And all it does is get rid of some of the random error.
Yeah. And so that was just built into the procedure then.
That's correct.
Yeah. Well, that's cool.
It was interesting because one of the things, after we taught like 100 different people this procedure, and part of the training we did for ultrasonic thickness was they had to go out into a unit, pick a unit, and take thickness data. And some of it was 350 degrees, some of it was ambient, et cetera, et cetera. And they would have to pass that test. Well, over a few years, we collected a lot of data. And what we saw was the difference in the quality of the data when we first started and when we were at the end, where we were taking the 3 measurements and averaging them, that type of thing, getting rid of random error. The quality of the data just improved dramatically.
I mean, it makes sense. It definitely makes sense. If you take that one spot, you're trusting that the tech, nowadays the tech, at that one point, at that one time, got it just right, as opposed to having them repeat it 2 more times. And
correct.
Yeah.
And of course, in the training program, we were able to show the technicians the change in the quality of the data. So they became aware of the importance of what they were doing and how it could be much better quality if they did it correctly. They take pride in what they do, just like all of us do. And it's a matter of educating them on how important what they're doing is, as well as there are ways to get the correct answer.
Were you driving that level of quality and that procedure as the inspection supervisor?
Yes. Yeah, okay. I started that, and I was in the central engineering group in Deer Park. I started the program to try to improve the quality. And then when I became the inspection supervisor in 91, we implemented that at the Wood River refinery, started doing it there as well. So it became, at that point, it started becoming a Shell US thing.
That's an interesting comment. I wonder how many people here realize, as far as the history of Shell, when the refineries in the U.S. were operating as a U.S. business unit and then transitioned back to a Royal Dutch unit. When did that all happen, Mark? And did you see many changes in the organization when during that transition or after that transition?
Yeah, it was interesting in that, of course, in the mid 90s, Shell had quite a few plants in the U.S. And when we merged with Texaco, we had like 16 refineries, chemical plants in the United States, like the few that they have today. So it was a fairly large group of refineries and chemical plants. And it was actually in the year 2000 that Shell, the vice presidents from different regions of the world, said we need to do things consistently, not just inspection, but maintenance, and et cetera, et cetera. We need to get better at what we do, and we need to be consistent. And so they implemented a best practice program. And I was fortunate enough to be the fixed equipment MI representative on that team, to where we normalize all the inspection practices globally, where we had the same IDMS tool, and same very similar procedures, things like management change became consistent. So I got to see it evolve in the U.S., but then I got to see it implemented in Europe and Asia, Australia, South America. So it became a very interesting project to see how people accepted this change. We saw it gradually, they saw it dramatically.
Yeah, I've always thought that if people are going to manage enterprises across a spectrum, or geographically, or you've got multiple enterprises operating the same types of units and equipment, that there could be tremendous value in consistency and consistency of quality, so that you could internally benchmark and compare to just get better, part of continuous improvement, right? Did Shell view it that way?
Absolutely. And we had one primary vice president that had a vision that people would be consistent, that we would find the best way of doing something and do it consistently. There are other oil companies that do this as well, and do it very well. So I just got to see the growth of it in Shell, so I have that advantage point. And it was what we did was we brought all of the different areas of the world together into meetings. So I would meet with all the fixed equipment people from Asia, China, Australia, et cetera, and Europe and South America. And we would sit in one room and we'd come up and we say, this is the best practice. Now we use the US stuff as kind of a starting point because we had more documented. People like Reynolds drove that improvement in the US. And so once we had the starting point, once they accepted it, it became the way of doing it. And the leadership of the company says, you will do it this way. You're going to have some certain Shell statements and you shall do them. And so it became much more consistent. The concept of, well, we can do it our way works too, was no longer acceptable. You've agreed to a common way of doing it, you will do it. So it was the learning process, a change of how we looked at things. Is it okay to do things differently? Well, why would you do it differently? One person has to be doing it better than the other. It would make sense. And so pick the best one and do it. Learn from each other.
So would that team meet regularly to compare notes?
Yeah, for about 6 years, we met globally about once every 4 times a year. So early on, we met quite a bit, obviously, developing the global standards. And then we would meet like 4 times a year. And then, we also were developing technical networks like for NDE, for corrosion, for people around the globe, the corrosion engineers would have either face-to-face or teleconference and talk about issues. So you'd have these specialized groups trying to learn from each other as well. We call them TechNets, technical direction teams.
Those technical networks, I've heard of other companies doing it. I think it's a really good concept, to be able to have information sharing across a larger corporation like that.
It's the advantage of having the big corporation. And when you don't take advantage, I think you're losing a lot of potential strength. So I think that it was just like NDE. We had the NDE technical direction team in the U.S. And for several years I was over that team. I chaired the team, and we looked at things not just accuracy, but we also looked for things like efficiency. How many profile radiographies do you normally take in an 8 to 10 hour shift? And we started trending those throughout the U.S. And Canada, and it was like, once we started measuring it, we started improving it. Not just make sure we look for safety, obviously, not just speed, but it was a matter of how can you do this more efficiently? And we were actually seeing measurable increases in our productivity as well as in our quality. So what we saw was that by improving quality, we didn't lower productivity. You needed to focus on both at the same time. And it worked, but it was a matter of the team getting together and learning from each other.
Thank you for listening to Upon Further Inspection, a mechanical integrity podcast. This episode was co-created by Inspectioneering and Core Solutions. Our producers are Nick Schmoyer, Jocelyn Christie, and Jeremiah Wooten. This podcast is for informational purposes only and does not constitute legal or professional advice. Listeners should seek their own qualified advisors for guidance. If you enjoyed this episode, please join us next time wherever you listen to your podcasts. Until then, stay safe and stay informed.